Hello, today I want to talk about the volume of cones and using Cavalieri's principle to help generalize a little bit when it comes to the different shapes of cones. Like we can have a pyramid, or we could have a regular, like what we're used to, a conical type of cone with a circular base area. First, I want to talk about how to get the volume of a rectangular pyramid. So if I have a rectangle here, and it's got a height, say it's the center of it, and it's got a height of h, right? So let me just move that height out over here. That height, call it h. And let's say it has a length of x and a width of y. Now, suppose I make a box here, or another way of saying that, like a rectangular prism here, right? If I want to find the volume of that box, and the tip of the cone here is in the middle of that, of the top surface of the box. If I want to find the volume of that box, the volume of the box is equal to x times y times h, right? Well, the volume of the square pyramid is equal to some fraction, or a constant k that will be a fraction, of x times y times h. Because the volume of the rectangular pyramid is smaller than the volume of the entire box. So that's where the k comes in. It's some value that we don't know what it is yet that will reduce the product of x, y, and h. Now, let's say instead of taking the volume of that single prism, what if I make a pyramid and instead of having the height be equal to h, what if I have the height equal to h over 2? So it's half the height of the volume that I did over here, right? So we have x, y, and h over 2. And then let's say for the remaining height of h over 2, I have another pyramid. That is the same dimension as this bottom pyramid. So then if I want to do the volume of the bottom pyramid and this top pyramid, I just find the area of this the volume of the bottom pyramid and multiply it by 2 to get the volume of these two. So the volume of the bottom pyramid is, and I'll call this pyramid pyramid 1, and I'll call this one pyramid 2. So the volume of pyramid 1 is equal to some constant k times x times y times h over 2. Right? And the volume of this pyramid V2 is equal to the same thing. So the volume of both of those pyramids is equal to the sum of both of those, which becomes 2 times k times x times y times h over 2. The 2's cancel, which gives you k times x times y times h. Now, let's say I want to find the volume of this pyramid here. Okay, so this is the base here, and then it's got a height over here, right? So the distance from here to the center here of this rectangle is x over 2. So the volume, similarly, of that pyramid there, I'll call this one pyramid 3, is going to be some constant k times x over 2 times y times h. So this is the height, and these are the two sides. We have a similar pyramid over here on this side with identical dimensions. Okay. So that pyramid, which I'm calling pyramid 4, is going to have the same area. So the volume of 3 and 4 is going to be 2 times this, which, like in the other case, is going to be k times x times y times h. And then we have 2 more pyramids. We have one here. All right. And so that pyramid is going to have a height of y over 2. I'll call this pyramid 5. So the volume of 5, it's got a height of y over 2. It's got a side of x and a height of h. And then multiplied by the constant gives you the volume of 5. And the identical pyramid 6 on this side is going to have the identical volume because the dimensions are the same. So the volume of pyramid 5 and 6 is going to be equal to k times x times y times h. So the volume of this entire rectangular prism, we know is just the length times the width times the height, which is going to be equal to the sum of all these rectangular pyramids. So V12 plus V34 plus V56. So that's going to be equal to 3 times k times y times k times x times y times h. So that's equal to 3 times that. So if I want to find out what k is, what this constant is that helps me that I need for the volume of the pyramid by itself, I just take x times y times h equal to 3 times k times x times y times h. These cancel, leaving me with 1/3 is equal to k. So now I know 1/3 is equal to k. So the volume of a square pyramid is equal to 1/3 times x times y times the height of the pyramid. So now we know the volume of a pyramid with a rectangular base. All right, now we'll keep that in mind. So now let's say I have my pyramid, and let's say I have a cone, and let's say it's given that the base areas are the same. So somehow we measured the base area of both of the circle, and we measured the base area of the square on the base of the pyramid, and we found that those two numbers are the same. And then let's also say that given the heights are the same. So we have a height h. That's the center, about the center there of that pyramid. A height h, and then here we have also the height h. It's the same height. And then so we know that the base areas are the same and the heights are the same. Now, if I want to know if these two pyramids have the same volume, then that means that at any point along the height of this pyramid and the height of this cone, I should be able to take a cross-sectional area, maybe an area like this, and then a cross-sectional area here. And if those two areas are the same, all up and down along the cone and the pyramid, if every one of those slices have the same area, then it stands to reason that the whole volume of both of those is the same from Cavalieri's principle. And if you haven't watched Cavalieri's principle, again, I encourage you to go watch the video on that. So let's see if we can prove that the area of those two are going to be the same. Well, if I draw a straight line straight down the middle from the tip of the pyramid to the straight down the middle of the area halfway down and straight down to the middle point of the base of the pyramid, and then I draw a line out to the middle edge here of this pyramid, and then a line all the way back connecting to the top. And then if I connect the middle line of the middle area, the middle point rather of the middle area to the end of that intersecting line, then we see we have two congruent triangles. So because we have two congruent triangles, then I know that, let's say this is x, and let's make it, just to keep it simple, let's make that length also x on that side. But if I have a length x here, then that means that this length here is going to be x over 2 because it's halfway up and the triangles are congruent. There's that proportionality there because of congruent triangles. And then let's say that I draw a similar triangle down to the bottom, through the middle there, out to the edge, back up, and then in the middle area, drawing a straight line over to the edge. We see we have two congruent triangles there. Let's call this radius r. Well, then I know that this there is going to be an r over 2 in length, right? Because of the congruency of the triangle, and we're halfway up. If we find the area of both of those, we get the area of that square is x over 2 squared, which is equal to x squared over 4. And here, the area of that circle is going to be the radius, which is r over 2 squared multiplied by pi, which is going to give me pi r squared over 4. So now let's take a look at this. We have those two areas. What's the area of the base of the pyramid, of the base area? Well, its area is equal to x squared. And what's the area of this base circle? That's pi r squared. Well, when we compare this area and this area, we see that the area halfway up is 1/4 the area of the base. And also here, if we compare these two, we see that the area is 1/4 the area of the base. So since they're both the same area at the base, and we know we're 1/4 of the way up, I mean 1/2 of the way up, we're 1/4 of the area of each of those, then both of those areas have to be the same. And because we're dealing with congruent triangles, then all the way up and down that cone, the area at any one of those points is going to be the same as the area on the other object at that same height. So now that we know the areas are the same all up and down the cone and the pyramid, then we know that the volumes are the same. The volumes for both of them are the same, the pyramid and the cone. That's because of Cavalieri's principle. So now let's see if we can just have the general formula for the volume of a cone. The volume of the pyramid is equal to 1/3 the base area times the height. And since we know it's equal now to that one, and we know that this one also has the same exact height as the pyramid, and if we imagine there's a third in there, then all that's left between the two, because we know the base areas are the same, is the base area. So we have pi r squared. So this is a base area, and this is a base area. So the general formula is 1/3 the base area times the height. So hopefully that gives you a little bit more of an intuitive feel for why that formula works, the 1/3 base area times the height for any kind of a cone. And I'll catch you next time.